亚洲产业文化资产平台，也就是我们说的 ANIH， 是一个亚太地区的跨国产业文化资产平台。这个平台呢，是以多边的交流、还有资讯共享、还有跨域协作作为精神跟目标。我们希望来推动文化资产区域性和主题性的国际交流合作。长期以来呢，ANIH 我们盘点了亚洲产业文化资产的经典案例，还有名录。也梳理了亚洲产业文化资产的体系还有脉络，而这些学术资讯都可以在 ANIH 网站上看到。此外，还有这个半年期的这个期刊，提供专业的知识分享。每年度的这些论坛，我们也邀集了专家学者还有青年人齐聚一堂，大家共同来进行传承还有交流的活动，以及各式各样的讲座推广的这些活动，也都在这里发生。平时大家也可以关注 ANIH 的一些 Facebook， 还有 IG， 还有 Twitter， 我们可以了解到全球产业文化资产的最新趋势还有讯息。大家都了解到，现在是一个数位的时代，每一个人呢都可以透过知识型的这个影片来做线上还有线下的自我学习。也因此呢 ，ANIH 的线上学习专区，我们希望用各种的影片，以有趣而且容易了解的方式开出亚洲各国不同文化资产领域的这些佼佼者，还有研究学者，他们多年的经验和成果，借由这些无远弗届的网络，把这些知识传播给更多的人，让大家更容易参与，而且乐于学习，让文化资产走进更多人的这个日常生活。我觉得这是一件非常美好的事情。ANIH 这一个系列的线上学习的影片呢，我们将介绍各式各样的产业文化资产，带领大家发掘我们身边的文化资产记忆，也带领大家来发现产业文化资产的这些历史，还有一些认同感，还有转型以及永续发展的世界趋势。我们会发觉，其实他们离我们并不遥远，他们就蕴藏在我们的工作、我们的经济发展和社会脉动当中。而文化资产的价值，还有文化资产的思维，其实就蕴藏在我们的生活之中。也因此，希望大家能在欣赏这些影片之后，能够有满满的收获，同时更关心我们生活周遭的文化资产。谢谢大家。
三角埔发电所位于台北天母地区。那三角埔是天母地区的旧名，1931年完工，是全台第一也是唯一自来水发电的发电厂。三角埔发电所面积155平方公尺，为钢筋混凝土造房屋，内置有发电机、水车等设备。出入口另有一座面积27平方公尺的警卫室，整体建筑保存良好。于民国87年，三角埔发电所正式走入历史，并改为自来水加压站。那三角埔的地形与水自然资源，我们不得不提到草山水道系统。草山水道系统兴建于1928年至1932年间，属台北水道系统第2次扩张工程。1895年，后藤新平以卫生顾问来台，聘请英国技师威廉巴尔顿先生担任专案技师来台进行卫生工程及水道建设相关调查，并且设计28处都市水道系统改善。日本在台的首要工作为改善自来水用水品质，并改进供水量不足的问题。当时日本人多方在阳明山勘察，找到3处水源，分别为阳明第1、第2及第3水源。主要考量水质洁净，不用再经过过滤设施，节省工程经费，尤其以阳山水源为表率。阳山水源标高为303.69公尺，三茂山为600公尺。三茂山的地质是属于火成岩安山石，涌泉经过三茂山层层过滤后，水质洁净，富含矿物质，有蓝宝石水的美称，不用经过其他过滤程序，其实已经符合环保署公布的饮用水标准。由此可知，草山水道系统是全台罕见的设施，保存完整。更重要的是，目前仍在使用中。因此，台北市政府在民国93年4月28日 把草山水道系统公告为台北市第111号市定古迹。
Hello and welcome at the Sanjiaopu Hydropower Plant Historical Site. My name is Stefan Tkac and I'm an Associate Professor and the Chair of American University of Phnom Penh Department of Architecture. I've been researching Taiwanese hydropower plants since the year 2012 and I get the chance to visit every single unit on the island. Currently, I am leading the Slovak-Taiwan Hydropower Laboratory, where besides the modern hydropower plants, we are also dealing with the historical sites just like the one on the back. Sanjiaopu hydropower plant was built in 1930, basically between 1930 and 1931. Specifically, the construction started in June 1930 and ended in January 31st, 1931. But the electricity started to be generated in April, the beginning of the April 1931. The reason for that is basically the reason that we are using in the modern hydropower plants as well, and that is a testing period, which is about 4 months. Taking the case of a Sanjiaopu hydropower plant, what we immediately notice are the clear horizontal lines which we can see on the roof eaves or the monitor top. They are even emphasized by the river stones, right? So they are kind of darker. Even the structure is a little bit more rough in contrast to the rest of the walls. Another things are the issues with the geometry regarding the windows. There have been used standard Japanese windows, which were used in most of the buildings of that time. And they were either sliding or flipping. Specifically in case of the machinery room or the machinery hall, where we have the turbine and the generator, basically all the technology that was generating a sufficient heat, and it had to be ventilated. Those windows were actually flipped windows. Their purpose was to basically direct the wind flow inside the building. When the air was heated up by the working technology inside, then it basically escaped through the roof, through the monitor top that we can see on the very top of the building. Really interesting parts about this industrial building is the entire ventilation system. As we can see, every single window on the bottom has got these ventilation slots. They were literally sucking the cold air from the bottom and using the chimney effect of, again, the monitor roof to basically keep the air circulating within the building. So that was the only way how that time a heavy machinery could be cooled. And we can see that thing in lots of industrial buildings, especially during the Japanese occupation period. Another quite interesting feature is the asymmetric plan, right? The machinery room, as the main and the most important part of the building, is in the center. However, multi-purpose room, which is the one over here with the shaft, the revision shaft, or the office that is left side, those are in an eccentric position. And the entire building is not facing east, which all of these elements were actually features of the second part of the Japanese occupation period. In a contrast to Uechi Nagano's design of the presidential palace, or nowadays presidential palace, the Taiwan Governor General, they were all facing east, as the resemblance to facing to Japan. This is a plate of Sanjiaopu Fadian source. Now there are a couple of interesting things about this plate. One of them, which you probably noticed, is that it is still painted in this kind of camouflaged style. Now, to make you understand why this still happens as a residuum of the old era, is because most of the hydropower plants during the Japanese occupation period, especially the last part of this occupation period during the World War II, they were considered strategical objects, which means they were basically military strategical objects. They were supplying electricity, or basically their job was to generate electricity for most of the essential equipments, or including the cities. So basically every single hydropower plant, not only Sanjiaopu, were painted in a camouflaged style. So the aeroplanes won't simply see them from the air when they were making their raids. We are currently in the machinery room of the Sanjiaopu hydropower plant. There are two industrial heritage elements. The first one is the hydropower turbine, right? And the second one is the hand-powered crane. Both of these elements are basically adjustable by a hand, which means you don't need any electricity to adjust it. You don't need any hydro servo engines or anything else, which are actually in the modern hydropower houses. This hydropower turbine, right, is actually coming from Japan, from the group Hitachi. The generator that was originally coupled over here is also from Hitachi. At the moment, the generator is somewhere in the Gongguan water treatment facility. In 1970, the hydropower plant simply ceased the operation, and the generator could also be turned into an electric motor, right? And in Gongguan pumping station, they actually needed a spare electric engine for the pump. So that's why it was actually shifted into Gongguan. We have the turbine runner, right, which is inside the casing, right? We can actually hear it, that's a casing, it's made of steel. Then we have a shaft, which actually connects the turbine with the generator. And there was most likely a flywheel over here to deal with the potential vibrations, at the same time to helping to brake the turbine, right, or accelerate the turbine. There are two bearings, one over here and one on the right. This part and that part over there are basically dealing with the oil pressure, because most of these elements over here, despite the fact that they are actually hand powered, they still go through hydraulics. Now another thing is the bearing, which is actually supplied by the oil system because of the obvious reason it needs to be lubricated. So a Pelton turbine is a very specific turbine because it's dealing with the high heat and low flow volumes, right? Which means we need basically a high mountain and not that big stream of water, which is actually ideal for the case of a Sanjiaopu hydropower plant because it was built on Caoshan waterwork. Caoshan waterwork in Taiwan was the second stage of a drinking water for Taipei City. So basically what happens, we had the high heat, right, and a relatively small flow volumes, which is exactly ideal for this turbine, right? This turbine is called an impulse turbine, which means it has two jets, one over here on the top, and another one is over here on the bottom. We can actually see these two pipes. So what happens is, we had the inflow pipe coming right over here. There was a big valve that was protecting the turbine and regulating the flow of the water. And then it splits into two pipes, one over here and one over there. Inside, we have a needle, or in case of a larger turbine, we call it a spear. And on another side, we had actually a system that was governing these spears. Basically, what happens is that the spear moved inward and outward. We can actually see the system over here, right? There is a lever. And the moment the spear goes out, basically the water jet, right, was stronger. The moment it gets inside, the opening was blocked, and basically there was no water coming into the turbine, so the turbine was not working, right? But basically you stop the turbine, right? Now, how this runner look like? A Pelton runner is a very specific runner that was designed somewhere in 1870s, right? Which is actually an incredibly old technology if you think about it, right? It was designed based on a standard water wheel that we are actually still seeing somewhere around the Taiwan, right? For like pumping the water or for the agricultural purposes. So the Pelton runner is, let's say, a modification of this standard water wheel. Now what happens is that it has, instead of these kind of small paddles, it has buckets, right? And anytime the water jet basically hits the bucket, the turbine turns, right? That's why it is called the impulse turbine, because every single time the jet hits the turbine, it actually gives the energy of the water, and then the turbine turns. So basically it was the impulse, right? And then you got another buckets coming in and you had the second impulse, right? And that's how the turbine actually turns. The problem with the impulse turbines is that sometimes they have vibrations, right? They came to a really steady vibrations. However, they are not really good for the generator, and that was the reason why the flywheel was over here, probably connected between the generator and between the turbine, right? All connected by the shaft. Let's look at the bottom of the turbine, right? The Pelton turbine technology is actually an open technology, which means one can go under the turbine and actually still see the wheel, right? So in theory, if we go under the turbine right now, we will probably see the Pelton runner still, kind of being over there. Another thing that I forget to mention is that inside this jet over here, right, we have a spear, and then at the end of the tip of the spear, there is a deflector, which engages all the time when you basically turn the turbine off. This is to protect the wheel, this is to protect the spear, right? So basically it actually closes the spear and protects the tip. Now, how the spear was governed? We call this thing a governor, right? Which is over here, this shaft that was most likely connected to a flywheel, right? As a kind of a brake, right, connection. Unfortunately, we don't have a flywheel over here, so you can clearly see that it was actually cut off, right? It was cut off, but you can still see the connector over here, right? So there was a secondary shaft or something else over here. All right, now this is the governor wheel, right? And the reason why it is so big is because through the transmission, right, through these handles over here and over here, it was actually dealing with the mentioned spears, right? So basically, the moment you turn the wheel, the spears goes in or out, or in other words, you are basically regulating the revolution of the turbine. Usually when you kind of turn it towards yourself, right, you will basically breaking the turbine, you are closing the water flow. If you are turning it away from yourself, right, then you are actually speeding up the turbine. In this case, we have the hydropower turbine that is actually designed on the drinking water pipeline, which is the only case in Taiwan that we have. We don't have any other turbines, as far as I know, that's been designed on the freshwater pipeline. This is the second bearing, or the end bearing. There was nothing else over here, right? So this is where the shaft that was connecting the turbine, flywheel, and the generator ends, right? As you can see, this is the oil pipeline connecting the bearing with the oil pressure systems, right? The lubricating, and once it is turning, so it is smoothly turning. Now this is the main valve. Once we turn it off, basically there was no water coming into the turbine, and you can maintain the turbine. You can actually go underneath the turbine and check the turbine from the bottom, check the turbine from the top. You can basically disassemble the whole system. You were protected. And then we have the second valve over here, which was the valve that was basically braking the turbine, right? The moment you basically close it, you brake the turbine. You will basically stop the turbine from spinning. So this was the way to open it, right? And this was the way to close it. This is a pressure gauge, which is one of the most important parts in the Pelton runner or any kind of hydropower turbine. And basically what it does is, in this particular scenario, it is telling us the pressure of the water that was actually hitting the individual buckets of the Pelton runner. Right? So basically the higher pressure we had, the faster the runner would be spinning. And with the help of the governor, we can actually govern the speed, govern the revolution of the turbine. Part of the Sanjiaopu hydropower plant was also the switchyard. Electricity that was generated in the powerhouse went through a switchyard, and then originally it was supplying the Gongguan, probably pumping station, because that's where the electricity was needed. Obviously right now the switchyard is not over here, but what we know from the historical pictures is that the switchyard was actually consist of 3+1 transformers. One transformers were basically a spare transformer that was used when something happens with those three, or basically you had to kind of switch them, or you simply want to maintain them. The problem with the electricity that was generated over here at this space and that was delivered to Gongguan was that you had to actually use the power lines that were quite long. Now these power lines, that time, that means in 1930s, they actually had lots of losses, right? So there were lots of losses and they were not really economic. So what happens after a certain period, power from the Sanjiapu hydropower plant was basically switched directly to Tianmu area, or formerly known as Sanjiaopu, hence the name of the powerhouse.
那我们这些水源是从我们阳明山上阳一的水源合并阳山的水源之后，经过我们的调整井、气瀑室，一路送至我们395发电所。现在我们阳一的水源是在夜间离峰才有多余的水合并到我们阳山的水源，再经过我们的气瀑室一路放至我们的配水池，再供应给用户。主干管的部分是属于市定古迹111号的，那我们经由跟文化局协调，现在的水就流往我们天母高地配水池。天母高地配水池的水位调整之后，再放流给民众。过往的尾水沿着干管一路到中山北路，我们现在目前阳明分处旁边有一个圆山配水池，它后面有一个水神社，从阳一到阳山到三角埔到水神社，这是一个带状的古迹。那这是市定古迹111号所有的建物。那目前三角埔、阳山在每年的3、4月的时候会有水稻季，那是由草山协会跟在地的民众一起来参与。我们为了保持水的洁净跟生态的永续发展，所以每年会在3、4月开放。那也在去年因为疫情的开始，我们有在阳山开始有一些旅行团。每周3次，为了保持我们水的环境而订定这些标准。以我们现在草山系统来讲，我们仅开放阳山涌泉供民众参访。那另外，我们自来水事业处还有开放公馆的水博馆，也欢迎民众参加。